Yes, guys. So we are doing question number 13 to the last one. Okay, so this I was doing in a very elusive manner. Okay, now I'm just solving this question. Let me take this up to the end. But the question here, let me continue. There was a disturbance in between. Question 13 so that the area bounded by the cardioid without the parabola. Okay, this we were doing without a parabola. The parabola is this and the cardioid is this. Now in this case, cardioid we have calculated this intersecting point is having theta is equal to pi by 2. Okay, so limits 0 to pi by 2. This I was doing here. The volume of the solid generated by the revolution of the cardioid without the parabola about the initial line this I have talked about already, that the formula is, that if it is about the initial line, and in case of sectorial sections, if I take this as the P and Q point, and this is R and R per delta d theta, this is delta theta, okay, and then the volume given is pi into RQ into sine theta if it is about the initial line. If it is about the line theta equal to pi by 4, where at theta equal to pi by 4, then it is cos theta. Okay, so pi RQ, this I have already discussed about. In this case, limits are 0 to pi by 2. This I have discussed, that intersecting point is having theta pi by 2. Okay, so this is pi by 3 pi R3 pi into RQ into sine theta d theta. Sorry, 2 pi by 3. This is 2 pi by 3. This I have already discussed about. And if it is, this is about initial line. This formula is used when about initial line it is. If it is about the initial line, try to understand. If it is about the initial line, then this we have discussed in volume in case of polar coordinates. Okay, in polar equations, we discussed about that the volume of solids of revolution. In case of polar equations, there are two formulae we were using. This is the first one, when any arc or the solid is revolved about the initial line theta equal to 0, then the formula is used as 2 pi by 3 into RQ sine theta d theta. If it is about the line theta equal to pi by 2, then it is 2 pi by 3 RQ into cos theta d theta. This is the difference. Now here in this case, it is about the initial line. Say about the initial line, then the volume generated is 18 pi AQ. This we have to prove. This is said that here, so that the difference line between the cardioid this and the parabola this. Okay, without the parabola this revolved about the initial line. So that we have to find out. So that I was writing here. This formula we have used. Now this I noted down. Again, let me note down this. This is 0 to pi by 2 limits. This is 2 by 3 pi into RQ sine theta, when this is for cardioid. This is for cardioid here. This is for cardioid. First one. This is first equation, and this is the second one here for parabola. I have solved these two equations, and after that we calculated the theta is equal to pi by 2, because I substituted value of r from both the equations. Then we obtained that 1 plus cos theta is equal to 1, or cos theta is equal to 0 we obtained. That means cos pi by 2, or theta is equal to plus minus pi by 2. This I have discussed already. And this is minus pi by 2, theta equal to, here theta is pi by 2. So this cardioid is, okay, without parabola is from 0 to pi by 2. This parabola also we will take from 0 to pi by 2 limits. Same limits we are taking here. This is for cardioid minus same formula, limit 0 to pi by 2. This I have already written down. Pi into r cube, again sine theta d theta. This is for parabola. Because we have to subtract the parabola's volume. Volume of the solid generated by the parabola, and from the volume generated by the cardioid. This is the cardioid here. Okay, this cardioid, theta equal 0 to pi by 2. Same we have taken here. So this is for parabola here. This I am discussing about. Okay, in the formula, in case of when any curve is revolved about the line at theta equal to pi by 2, then it is cos theta 2 pi by 3 r cube into cos theta d theta. This we have discussed in detail in case of volume of solids of revolution in case of polar equations. Okay, so this is about polar equation. This question is. So I have taken multi type of questions regarding parametric equations, regarding polar equations, regarding Cartesian equations. All kind of questions I have taken from 6th onwards. All right, and 5 questions I took based on that previous question of double integration. So that is the topic of this today. So I have taken all double integral signs, surface areas or surface areas of double integration in case of projection, and then I've taken this multi-type of questions from the topic discussed in the previous lecture series. So this is what I'm talking about. Now let me solve this whole equation. Therefore, the volume, the value of this we have to substitute. Let me take 2 pi by 3 common from both of them. 2 pi by 3 is common. So in first, this is 0 to pi by 2. In this case, r is the first cardioid. This is 2a whole cube into 1 plus cos theta whole cube into sine theta d theta. I'm sorry. Here this sine theta, into d theta. Sine theta into d theta here. This is also d theta. Okay, minus sign within the same bracket. This 2 pi by 3 are taken from both. This is sine of integral 0 to pi by 2. Here it is for parabola. It is 2a upon r is equal to 2a upon 1 plus cos theta. That means 2a whole cube upon 1 plus cos theta whole cube into sine theta into d theta. Okay, so difference of these two volumes we have to find out. Now let me solve these two equations and subtracting them from first the second one. Let me find out the volume of the solid obtained after subtraction of this parabola's area from the area of this cardioid. Okay, this arc only and this arc only, because we are revolving this about the initial line. So this whole solid will be obtained after revolving this upper portion of this arc here is from C to A. So C to A arc is revolved about this initial line, and this B to A is also revolved about initial line, and then we have subtracted. We have to find out the volume of solid is after subtracting this parabola from the cardioid, and this blank space, this blank one, this solid is obtained, and the volume of that area, subtraction of this area, is to be revolved about. Okay, solid is revolved about this initial line, then volume is obtained. That volume we are calculating here. Okay, now let me further write it down. This is 2 pi by 3. Now here 2a cube, both are having common. So let me take this 8a cube out. It will be 16. 2 into 8, 16 pi a cube. I have taken outside. 8a cube I have taken outside, so it will be 16 pi a cube upon 3. Now in this case, this is 0 to pi by 2 into 1 plus cos theta whole cube into sine theta into d theta minus sine 0 to pi by 2. Okay, in this case is this 1 upon 1 plus cos theta whole cube into sine theta in the numerator and the denominator into d theta. Now if I substituting 1 plus cos theta, let me take equal to t. What it will give us? It will give us minus sine theta after differentiation with respect to t, sin theta d theta is equal to dt, or sin theta d theta is equal to minus dt. What are the limits here? Putting this, we have put here in both of these, putting 1 plus cos theta equal to t and differentiating with respect to t, we get this we have obtained. And the limit, what are the limits here? Let me talk about limits here. Limits, if I put theta as pi by 2, it will be 1 plus 0, because cos pi by 2 is 0, t is equal to 1. So at theta is equal to pi by 2, t equal to 1. T is 1, why? Because this is 1 plus 0, that means t equal to 1. This is equal to t, we are substituted. Okay, so that is there. Now, and at theta equal to 0, it is cos 0 is 1, so 1 plus 1, 2, t equal to 2. So at theta equal to 0, t is equal to 2. So limits here are, this is with minus sign here, because minus sin theta d theta is there. It is minus dt. Minus dt will give us minus 16 pi aq upon 3. Now here limits are 2 to 1. This is limits 2 to 1. Now if I change this minus sign, then this limits will be interchanged, and this is now tq into dt. Minus sign I have taken outside. Minus sign, this is 2 to 1. This is 1 upon tq into dt. Okay, so if I change this minus sign to plus, then the limits will be interchanged. So let me write here since. Let me write here since limits, if it is a to 0 and it is a minus sign into fx dx, then it will be equal to positive fx dx, and limits will be interchanged 0 to a. So similarly here we have to do the limits interchanged, minus sign will be removed. Then this is property of definite integral. Let me write here, this is 16 pi aq divided by 3. Now limits are 1 to 2. Now this is tq only into dt, minus sign. Now let me adopt this. This is now t raised power minus 3, 1 to 2 limits. This is t raised power minus 3 into dt. Can be now integrated easily. Now let me integrate this. After integration with respect to t, this is 16 pi aq upon 3. Sorry. Within this is integration t4 upon 4. Tq integration is t4 upon 4. T raised power minus 3. It means this will be t raised power minus 3 plus 1 upon minus 3 plus 1. Limits now 1 to 2. It is 16 pi aq upon 3. Here, if I put 2 here, this is, let me first write down in proper manner. This is now plus minus minus. Minus 2 is there in the denominator. This plus sign now. It will be 1 upon 2 into t square. Minus 2 plus minus 3 plus 1 is minus 2. T raised power minus 2 can be written as 1 upon t square. Limits is now 1 to 2. So this is equal to 16 pi aq upon 3. Okay, so that will give us now, if I put 2 here, so it will be 16. 2 raised power 4 is 16 upon 4. Upper limit I am putting first, plus 1 upon 2 into 2 square is 4. Then minus sign lower limit if we substitute here. Okay, this has become plus sign now. This is minus sign, both will be minus sign now. When we put lower limit, it will be 1 upon 4 minus 1 upon 2 only. Now let me solve them further. So solution of this will give us, we are calculating volume of the solid obtained, okay, without the, sorry, of the cardioid, volume of the solid obtained by the revolution of the cardioid without the parabola. Okay, the revolution of the cardioid without the parabola about the initial line. About the initial line. This is the point here, which I am writing again about the initial line. This is the final answer. Let me write it down. 16 pi. This is a cube upon 3 within bracket. Now it is this value 16 or 16 upon 4 is 4 plus 1.8 minus 1.4 minus 1.2 only. Okay, so now let me further solve it. Within bracket, what do we get? This 16 pi into a cube upon 3 in bracket. Let me take 8 common LCM. I mean 8 LCM. If I have taken 8 for the 32, my plus sign, it is 1 only, minus sign 4 to the 8, so it is 2 only, 2 for the 8, so it is minus 4 here, 2 for the 8 minus 4, so it is 33 minus 6, it means 27, or we can say this is 1 minus 2 is minus 1 minus 4 is minus 5, 32 minus 5 is 27, 16 into pi a cube upon 3 into 27 upon 8, so 3 9 is 27, 8 to the 20, 8 to the 16, 3 nothing but 18, 9 to the 18 pi into a cube. Is it the same answer here? 18 pi a cube is the same answer. This is the hence proved. Same answer, same volume is obtained. Hence proved. This we have to prove here. 18 pi a cube we have to prove. This is the total answer, I mean, of the 13th question. Now finally we have done all these questions. Students' queries were there. These questions are now clarified. Next I will take what is the next topic that I'll discuss in the next lecture series. There is one more lecture series. In that we will discuss about some theorem. Okay, based on that theorem we have to discuss about. So this is question number 13 we have proved here. Okay, then see you in the next lecture series. Okay then, bye bye.